we, the people in the space community, can not only affect what happens in the world today, we're not about giving the world Teflon, we're about giving the world freedom in our world. So what do? Next chart. Okay. This shows a mission C. You launch 2 more boosters off the Cape. One shoots out another Earth return vehicle. The other shoots out a HAB module with 4 astronauts in it. Next chart. Well, that shows the HAB module. Next chart. Okay, it's a basic tuna can HAB with a number of rooms and a solar flare storm shelter in the middle, which you can shield with provisions. You don't need extra mass to provide. Each time you do this, you add another HAB to the Martian surface. There is nothing in this that is fundamentally beyond our technology. You could do a near-Earth asteroid mission as a precursor, because a near-Earth asteroid mission can be done with a subset of the Mars hardware. In other words, I'm not proposing a near-Earth asteroid program. I'm proposing that you set your goal on Mars, and in the course of doing that, there are certain other activities where you exercise a subset of the Mars hardware, which gives you greater confidence and have a certain value in themselves. And a near-Earth asteroid mission could fall into this class. So there it is. The amount of technology we have to develop to accomplish this plan is modest compared to what had to be developed to do Apollo. Make a bold recommendation to Mr. Obama that he seize the time and move America forward in space. A free future for humanity. And that's what space is actually all about. Otherwise, none of us in this room would be interested in the subject. And so, therefore, that's what it is. And ultimately, look, what are the stakes? What are the stakes? There's 2 visions for the human future right now, that, and for a number of years, that have been in currency. The closed future, the open future. The Soylent Green future, or the Star Trek future. Okay, these are the 2 visions that are out there, what the human future might be. The closed future, the future where human beings are confined to one world, a world of limited resources, where human prospects become ever more severely constrained in order to somehow try to manage it. We're about giving the world freedom.
Could you comment on that?
Yeah, there is no question in my mind that having humans, especially experienced scientists, in the field, doing field work on another planetary surface adds value. And I think they will add value on the moon, they'll add value on asteroids, they'll add value on Mars. My point is, the more complicated the environment, the more value they add. And if they add some value on the moon, they're going to add even more in a more complex environment like Mars is.
Mars is the next logical step in our space program. It's the challenge that's been staring us in the face for the past 30 years. It's the planet that's most likely Earth. It's the planet that has on it the resources needed to support life and therefore someday technological civilization. Mars is where the future is. Mars is the closest planet to the Earth that has on it all the resources needed to support life and therefore technological civilization. It has water, it has carbon, it has nitrogen, it has a 24-hour day, it has a complex geological history that has created mineral ore, it has sources of geothermal energy. Mars is a place we can settle.
One reason for such optimism over a frozen world like Mars is evidence that 2 billion years ago, Mars was a much warmer and wetter place.
We think that at one time in the ancient past, Mars was very similar to the condition of early Earth.
This Martian warm age lasted for over 1 billion years and could have been a suitable environment for the development of life.
If we go to Mars and find evidence of a second genesis on Mars, I think we can conclude that the universe is full of life. We can probably conclude that on some planets that life evolves to more complex forms, and I think we'd be reasonable to conclude that intelligence could also emerge on some planets as well. It really does answer the question, are we alone? And that to me is a question that transcends science. It's a philosophical, societal as well as scientific question. To me, that's the big prize. That's why Mars is interesting. That's why human exploration makes sense.
That happened with the Apollo program, which was, if we can go to the moon, we can, and then everybody's filled in whatever they were interested in. Build mass transit, cure cancer, do this, do that. The point is, it did give us a sense that we could accomplish great things. It did bring out the best of us.
We excited a generation of engineers and scientists, the generation that built the computers and cell phones and all the technology everybody uses.
Why is NASA stuck in low Earth orbit? The problem with NASA's lack of current achievement is not money. The problem is lack of focus, it's lack of a goal. It shouldn't be humans to Mars in 50 years. It should be humans to Mars in 10. We can do this. We do not need gigantic nuclear electric spaceships to send people to Mars. That is pork, it's nonsense. The primary question I get from the American people is, why aren't we doing this? There's a big sense of disappointment, almost verging on a sense of betrayal. The purpose of spaceships is to actually travel across space and go to new worlds, not to hang out in space and observe the health effects from doing so.
You know, back in the days when medieval man was looking out from Europe and thinking about exploring the world was unknown, and map makers populated their maps with dragons. We've got the same thing today. There are people who are afraid to go out into space, and they've populated their maps of the solar system with dragons.
In the Mars Direct plan, Zubrin envisions a central, insulated core where a crew can retreat to while the radiation passes by. The core would be surrounded on the lower level by all the provisions of the mission. This should stop any harmful dose of radiation from reaching the astronauts. Fortunately, solar flares are predictable, and the crew could be forewarned by astronomers on Earth.
Basically, you use your pantry as your storm shelter. So a solar flare happens, the alarm bell rings, the crew goes into the storm shelter, they stay in there cramped up pretty tight for a few hours until the all clear rings and they come out. This is going to happen once, it might happen twice in the course of the mission.
The HABs will be interconnected, and a permanent human presence on Mars will be established. This scientific community will have to learn to become self-sufficient, to be able to survive on Mars without supplies constantly being sent from Earth. But unlike any other planet in the solar system besides Earth, Mars has all of the fundamentals needed to make this possible. Its 24-hour and 37-minute day is critical for growing plants. It has all of the elements necessary for creating building materials like plastics, metals, and glass. And it has oceans of water frozen into the soil. Eventually, with a lot of ingenuity and invention, the scientists will learn to live off the land. They will grow crops in the iron-rich but potassium-poor soil. And they will produce oxygen and energy from the water and atmosphere. With time, more and more people will arrive. These won't only be scientists, but settlers, people who plan to stay. They may come for all kinds of reasons, political, religious, economic, but to them, Mars will be a chance to start over, to build a new life.
We know how to warm up planets. We're doing it on Earth by putting gases in the atmosphere. On Earth, it's not a good idea to warm up the planet. The temperature is just fine, thank you. We don't need it any warmer here. But in principle, if you could trap the sunlight reaching Mars today, every single photon that's hitting Mars, Mars would warm up in about 10 years. Well, obviously you can't trap every single photon that's hitting Mars, but you can trap about 10% of them with the greenhouse effect. So that would imply that Mars could warm up in about 100 years. Well, 100 years is a long time, but it's not astronomically long.
One idea is to build small, automated factories that produce super greenhouse gases with no ozone-depleting side effects. Although these gases would be unwelcome on Earth, for the Martians they would be an efficient way to trap heat.
Then within a few decades, we would raise Mars by more than 10 degrees centigrade. And if you did that, that would cause massive amounts of carbon dioxide that is currently absorbed into the Martian soil to start to outgas.
Carbon dioxide is also a natural greenhouse gas. As it builds up in the atmosphere, more and more heat will be trapped, which will in turn cause more CO2 to outgas. Human colonists could discard their pressure suits and walk around the surface of Mars carrying only a supply of oxygen.
What you have here is a 20th century mind trying to address a 22nd century problem. And so I think Mars will be terraformed by the 23rd century. Not by the 33rd, but the 23rd. Things that would seem utterly fantastical to us is how it will actually be done. But it'll be done.
The thought that you could overturn a rock on Mars and see that, maybe, would be pretty exciting.